Hi guys. The question was posed, how can I find the area using integrals? So I'm going to look at number 17. So I did 17 kind of two different ways. Up here at the top, what we can see is that I'm just integrating from 0 to 2. So just from 0 over here to 2. Remember, when we integrate, effectively what we're doing is finding kind of an area between the curve and the x-axis. But if that curve is in the third or fourth quadrant, then our integral value will be negative. So this red section, that's my dog, sorry. This red section, when we integrate, will have a negative value because we're accumulating a bunch of negative y values. From 1 to 2, when we integrate, we're accumulating a lot of positive y values, so we end up with a positive. So when we integrate from 0 to 2, and we add up all of those y values, we end up with 2/3. But that's not what the question was asking. The question was asking for the area of the shaded region. So we have to be super careful about how to find area. So what I did down here is in the purple, we can kind of see the area that I'm going for. And I'm going to break this effectively into 3 regions. The first region is that little red piece from above, except I don't want him to have a negative value. So I'm going to take his absolute value. That'll give me the area, if I had to paint or color the red section, how much area I would be coloring. Then I'm going to look at this yellow piece. He's actually just a rectangle. He goes from 0 to 2, and then from the x-axis up to y equals 3. So he has a height of 3 and a width of 2. So this yellow piece has an area of 6. But to find the area of this purple shape, I actually do not want what was blue up above. So I'm actually going to remove the blue area. That blue area from above was found to be 4/3. You're welcome to go back and double check my work. And what I'm going to do is I'm going to add the area piece down here in red that had an area of 2/3. It had an integral of negative 2/3, but an area of 2/3. I'm going to add the rectangle, and then I'm going to remove the blue area that I actually don't want as part of my final answer. So I end up with the 2/3, the 6, and removal of the 4/3, which is what I did right down here. I just changed 6 to 18/3. Add across the top, right? 2 plus 18 minus 4, 20 minus 4, that's 16. Bottoms are all the same. They stay the same. Ta-da, there's my answer. There we go. 18, 19, 20, all are similar. I would actually argue 19 and 20 might be even a little bit easier. 17 and 18 are a little bit tougher, but very, 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 very similar to each other. That is it. Feel free to email if you have any more questions.